The main goal of the research activity here presented is to analyze and design devices to support walking mobility of visually impaired people based on electromagnetic waves. Such devices are aimed at improving autonomous motion and consequently the quality of life of people with visual disabilities. The work is the result of a collaboration between two research units of Polytechnic University of Marche, the Group of Electromagnetic Fields of the Department of Information Engineering, and the Group of Mechanical Measurements of the Department of Industrial Engineering and Mathematical Sciences. The working principle of the device proposed is similar to that of a radar. An electromagnetic pulse is radiated in the space surrounding the subject, and the reception of a possible echo warns of the presence of an obstacle. The main difference between the device proposed and a common radar used, for example, to survey airspace is that the possible obstacle and the radar antenna are very close. The distance, in fact, is of about a few meters. Moreover, the obstacles are very different in shape, material and position, and in some cases the traditional white stick, the aid blind people most frequently use, is not able to detect their presence. The system developed is of course a laboratory prototype, used uniquely to demonstrate the potential of the technique proposed. It consists of an antenna, a vector analyzer, and a PC. The radiating system is an helical antenna specifically designed and built for this study. At present, it represents the best trade-off among conflicting constraints of portability, lightweight, small size, and electromagnetic working conditions. The design features of the antenna are a good impedance matching in the frequency range from 4 to 6 GHz, working condition in the so-called actual mode, meaning that the electromagnetic wave is radiating along the direction of the antenna axis, and beam width of approximately 30 degrees. The metal cylinder at the base has been introduced to improve the antenna radiation pattern. By using the network analyzer, we can verify whether the antenna made meets the conditions regarding the impedance matching. As we can see, in the range from 4 to 6 GHz, the return loss is less than -10 dB, and therefore the requirement is fulfilled. The antenna radiates more than 90% of the power received from the generator. The computer completes the system and is used to drive the network analyzer and to process the data measured. The system works as described below. First, we need to emphasize that, in the present version, the electromagnetic pulse is virtually recreated by the system. The computer drives the analyzer to carry out a frequency scan, which is performed by radiating a sinusoidal signal with the frequency increasing from 4 to 6 GHz. The choice among the frequencies depends on the performance of the instrument, the size of the antenna, and the quality of the pulse we wish to obtain. The signal measured by the instrument at the antenna connector contains information on the surrounding environment as seen by the antenna at each frequency. The data measured are transferred from the analyzer to the computer, which compares them with a reference signal stored in the absence of any obstacles, and it finally gives back the time domain information. The pulse warns of the presence of an obstacle, and its location on the time axis shows the distance from the antenna. For obvious safety reasons, in the demonstration carried out, the obstacles used are cardboard cylinders. Since this material is practically transparent to electromagnetic waves, to increase its reflectivity, the interior was coated using simple aluminium foil for food preparation. The presence of the obstacle is signaled by a sound warning if the distance is about 2 meters, and by a double beep if the distance is reduced to about 1 meter. In the demonstration, a blind person who kindly accepted to cooperate for this project is asked to walk along a path with many obstacles. From a given starting point, the subject has to reach a target point represented by a music source. As we have just seen, the subject performed the test, reaching the goal in a few seconds without hitting any obstacles. In perspective, the work will be aimed at optimizing the system and at miniaturizing the components so that the device is easier to wear and less visible. A second demonstration was carried out to test whether it was possible to locate an opening, like a door, in a wall. Also in this case, the subject successfully achieved the aim. A different version, with a higher degree of difficulty than the previous one, is represented by a curved wall. However, even in this particular situation, the subject was able to locate the exit. We believe that the most significant test is the one aiming at verifying whether it is possible to avoid an object that is placed transversely to the subject's chest or head. As shown in the movie, this kind of obstacle is extremely dangerous because the traditional white stick can't prevent the impact. However, the radar seems to be very efficient in this case, since it signals the presence of the obstacle and therefore allows the subject to get around it. The researchers of the Polytechnic University of Marche who have carried out the study wish to thank all the people that have cooperated and have made these tests possible. In particular, engineer Angelo Cereser and Microlise, the company that supplied the network analyzer Agilent Firefox, CST, the company that provided the software for electromagnetic simulation, and Mr. Andrea Cionna, world champion in the marathon for blind people, for his useful suggestions and for his kind availability to test the system.